Okay, we've got ourselves in a position now where we got the two formulas. I put this down because I knew that's what it was. This, though, will allow you to find the size if you'd like. Okay, I probably won't have you do that. That's why I put it there. But if you wanted the size, this is going to produce a number, and this number is 5.14 inches cubed. Okay, since I have two of them, since there's two of those guys, that means each one is going to be half of that. So if I take 5.14 and divide it by 2, that's the section modulus required for each board. So 5.14 divided by 2 gives me 2.57. 2.57 inches cubed is the section modulus of one of whatever number I pick. So let's go. You guys know where to find your data for cross-sectional properties. That's table 4.1. Put my finger on the 2 column. I go across until I hit S. And when I hit S, let me see, what do we have here? Table 5.14 required. Using table 4.1, properties shown as requirement, the timbers, a double 2x4 would work. So a double 2x4 would be 3.06 or 6.12. So 2x4. So this warrants a 2x4. So it says two 2x4s satisfy the section modulus. Okay, if we go down below, and I put my data in now, I've got a 1406, I've got everything except B is now 1 1/2, H is 3 1/2. H is 3 1/2. Okay, I'm looking at seeing if the shear stress at those two 2x4s is less than the allowable. And we already did the allowable. Back a ways, you found out that 140 times 1.25 was 175 psi. So this number, if it's less than or equal to that, it would be okay. If it's greater than, it wouldn't be. So let's do it. 0.9 times 1406.25 divided by 2 divided by 1.5 divided by 3.5. Two minus, what's that? 2 minus, that's 7 divided by 12. 7 divided by 12. Subtract that from 2. I get 1 point. I multiply that by 120.53. And I get 170.75, and 170.75 is less than 175, and your book says that's okay, but they also indicated that since it's that close, they would probably use two 2x6s. So that was their suggestion. The numbers say, though, that two 2x4s would work. This sizes them. This checks the size. So this is 2x6. The book, two 2x4s will work. So I can use two 2x4s. You know, you may be a situation where down here, where it's high, you use 2x4s. Where it's less, you might end up like at the very top. Maybe you end up using 2x4s there. So these may be 2x6s, and this may be 2x4. So the less load, of course, selects less material you need to resist it. And that is where we'll stop. You do have some other issues. For instance, if you look at this guy right here, I've got two 2x4s or 2x6s, whichever I use. I've got a wall tie coming through. We got to put a washer of some sort on that wall tie. When the concrete comes in to the form, you've got this situation. Wall tie, washer, clinching device. That washer is going to try to squash that wood. Okay, if it squashes it too much, of course, that's going to leave the wall relieve a little bit. You're going to have a wall that, instead of being straight, is kind of wavy. So there are some other issues, but we're going to just get the main points, and the main points are what we've covered till now. So all we've got left is one more thing to do, and I'm going to go ahead and draw a picture of it on the board for a few minutes, and then we'll explain it. You've got all the tools to do it, whether you know it or not. It's the battered struts that keep the wall straight due to movement caused by workers and wind, and in particular, the wind. So we're going to shut it down for a few minutes right now and end up with a sketch on the board. So Masa, you want to shut us down?